Spooked yourself. Okay. So we want to evaluate this f of 3 if f of x is equal to 4x squared minus 5x plus 6. Okay, so the way that we're going to do that is we're going to take 3 and plug it in for every single x. So f of 3 is equal to 4 times 3 squared minus 5 times 3 plus 6. Can you guys see that green okay? Yeah. Okay, then we'll simplify. So we want to use PEMDAS. So we'll do 3 squared is 9. 4 times 9 is what? 36. 5 times 3? All right. 36 minus 15. 21 plus 6. 27. So 27 is our final answer there. That's really hard to see. Let's change the color. Okay, so there's a reason why we did this, and it'll kind of become clear to you in a minute. Okay, so we're going to talk about this thing called the remainder theorem or synthetic substitution. So notice that this problem and this problem are the same. Okay, so these two problems are the same, but the way that we're going to solve them is different. Okay, so I'm going to show you first how to do this. So go ahead and write down, evaluate f of 3 if f of x equals 4x squared plus 5x, or minus 5x plus 6. Okay, and then we have this setup. Okay, so over here to the left, that 3 in the box, that is this number right here. Okay, so notice that that number goes right there. All right, this 4, 5, and 6, oh shoot, that's not what I meant to do. 4, -5, and 6, those are our leading coefficients. Or just our coefficients, I should say. So there are coefficients. So that is the setup for our problem with that 3 in the box and the coefficients out front. Okay, and how we're going to solve these is always the same. So first thing we're going to do is drop down our first number. Okay, so that 4 just drops down. Step 2 is we're going to multiply by the number in the box. Okay, so we're going to multiply by 3. What is 4 times 3? 12. So 12 is going to come up right there because we did times 3 right here. Okay, then step 3 is add going down. So I'm going to add -5 and 12, which gives me 7. Then step 4 is repeat steps 2 through 3 until finished. Okay, so we added 12, got 7. Then we do 7 times 3 on the diagonal. What's 7 times 3? 21 plus 6?
27.
27. Okay, so I'm going to have this little number in a box over here too. All right, let's actually circle it. What that means is that f of 3 equals 27. Now, does that match what we had before? Yeah, it does. So we just solved this problem 2 different ways, but got the same thing. Take a second and get that all written down. Make sure you have those steps written down as well. So again, we drop down that first number. We multiply by that number in the box. Add going down, multiply, add, until we get to the final solution there. Okay. Another second. I'm going to move on here. All right, so the remainder theorem states if a polynomial is divided by, can't remember what we call it. I'm trying to think. The remainder gives you the value of the function, okay. I know this is r equals k, but whatever it is, this number over here is the remainder. I can't remember what goes in that box, if I'm being honest. Okay, so as long as you know that the remainder is what the answer is, the remainder is the value of the function, then that's what's important. So let me go ahead and write that down. Okay, so just write the remainder is the value of the function. Okay, we want to use the remainder theorem again. Okay, so notice we have 3, 2, 1, and then nothing. We want to make sure we have all the values. Now, for the setup, what value goes in that little box right there? Joelle? 4. That 4 goes in the box. All right, and then we want to write our numbers across the top. Does anyone want to give a crack at that? Yeah.
3, 4, 2, and 8.
3, 4, 2, and 8. Does anyone have any corrections on that? Look closely at those numbers. Chase? -8 and also a -2. We want to account for those signs as well. Simple fix can make a major difference in our final answer. Yes.
Where did you get the -2 from?
I got the -2 from right here.
Oh, I see.
Yep. We just took those coefficients there. Okay, so now we're gonna follow our steps. What's my first step? Drop down that first number. Okay, then what? Chase? Multiply by 4 because it's the number in that box. I'm not going to write these dotted lines. Sometimes it gets confusing. So 3 times 4 is 12. Good. All right, then now what do I do?
Can I stop you for a minute?
Sure.
I didn't see the first one you did. Are we multiplying by this number
No,
or by
the number
this
in the
one right
box.
here?
Number
The
in the
one in the box? Okay.
Yes. Good. Add 12 and 4. So add going straight down. What's 4 plus 12? 16.
Wait, what do you add?
Add the 4 and the 12. We're adding going straight down. Yep. We added the 4 and the 12. Then what? Trustee? Multiply what?
16.
Not 16, negative 2. 16 and 4. Yeah, the number in the box. We always want to multiply by that number in the box. So 16 times 4. What's 4 times 6? And 4 times 4? Sorry, 4 times 10 is what I meant to say. 40. So what's 40 plus 24? 64. All right, then what do I do? Joelle? Careful, not multiplying. Adding. Good. It's okay, we got a lot going on. All right, 64. I'm sorry, negative 2 plus 64. Emma? 62. All right, then we're going to do 62 times the number in the box. Box number. Multiply by 4. What's 6 times 4? 24. Add a 0, 240. 4 times 2? 8. So I get 248. What do I do with these two numbers? Yep, we're going to add them. So we get 240. That number in that box, or I'm going to circle it. I keep forgetting. That is our remainder. But it's also f of 4. You're probably thinking, it is so silly to be evaluating these functions this way. Why would we want to do that if we have an easier way of doing it, right? We could just plug it into our calculator. We could plug it into this equation that we are given. You're completely right. Okay, I also think that it's silly to evaluate this way, but there is a reason why we're doing this, okay? So this is kind of, a way to help understand that it has purpose outside of what we're going to do today. But also, we can divide this divide this way. So we can divide polynomials this way. Okay, so this is called synthetic division, okay? We're going to come back to this problem. Okay, so this is called synthetic division, and it's an alternative to long polynomial division. Synthetic division is an alternative to long polynomial division. Okay, notice that it says to factor, right? So when it says to factor, that usually means we're looking for, I'm just going to write something random. So like x minus 2, x plus 3, x minus 4, something like that, okay? That is what it's talking about. It wants us to take that and break it up into smaller factors. But we don't know how to factor an x to the third function. We haven't learned that yet. Or something bigger than x squared. So what we're going to do is we're going to use synthetic division to break it down just a little bit, and then we can factor it the rest of the way. So we're told that x minus 4 is a factor. So what I'm going to do is I'm going to set x minus 4 equal to 0. And solve. So I'm going to add 4 to both sides. And I get x equals 4. That number is the number that goes in the box. I still need to write these numbers across the top. So this is a 1, invisible 1, and this is an invisible 1. So my numbers are 1, -1, -22, and 40. Before we start, what I want you to do is go ahead and circle or highlight that degree, that highest degree right there. So go ahead and highlight that, circle it, whatever. But it is a 3. We're going to come back to that in a minute. I want you to go ahead and do the synthetic division on your own. I'll be walking around. So you're just dropping down, multiply, add, okay? Go ahead and try that synthetic division on your own. Yes, ma'am. Oh, I'm sorry. You're only multiplying by 4. So raise that there. You're only multiplying by the 4. The 4 is the number in that box. That was a little confusing. Sorry. Yeah. Sorry. Yes. Okay, so I think a lot of people are finishing up. I'm going to give you another second or two to wrap it up. If you think you're wrong, you're probably not. I've seen a lot of right answers out there. Okay, I'm going to talk through it to eliminate any confusion for those that just need to see it one more time with me. Okay, so first thing you're going to do is you're going to drop down that first number. On the diagonal, we multiply by the number in the box. So we're going to do 1 times 4 to get 4. Up and down, we add. So -1 plus 4 is 3. On the diagonal, we multiply by the number in the box. So 3 times 4 is 12. Add going up and down. So -22 plus 12, we get 10. -10, sorry. All right, we want to be careful of our negatives here. -10 times 4 on the diagonal gives us -40. And then what's -40 plus 40? 0. So my remainder is 0. You don't have to write out that this is the remainder every time. Okay, so we get a remainder of 0. That's a good thing, okay? That means that x minus 4 is a factor. I think, do I say that somewhere? Okay, so if we get, I would write this down. I'm not very good at writing and talking at the same time. Okay, so if we get a remainder of 0, then the number in the box is a 0 of the polynomial. Remember that 0 is also solution, root, x-intercept, 0, root, x-intercept, and solution. Those are all 4 mean the same thing. So if the remainder is 0, like this here, this means that this means that 4 is a solution, a 0, a root, all that good stuff. Okay? We're not finished because it does say to factor completely. So what we're going to do is notice that this was an x to the third at the very beginning, right? We had x to the third right here. What we're going to do is this first term, we're going to write x squared. So it drops down 1. So for x to the fifth, it becomes to the fourth, so on and so forth. This time it's x to the third, so it's going to drop down to an x squared. Then each of these goes in order. So x squared, x, and then no x. So this is plus right there. So I have x squared plus 3x minus 10. I'm going to zoom out a little bit more. Yes. I took this 3 right here, and I dropped it down 1 degree. So I made this a 2. And then I just went down from there. So then I said squared x to the first, x to the 0 is what I did. All right, so I'm going to rewrite this over here. So x squared plus 3x minus 10. Do we know how to factor something like this? Yeah. We need 2 numbers that add to be something and 2 numbers that multiply to be something. Our 2 numbers need to add to be this number in the middle and multiply 1 and -10 to get -10. Anyone think of those 2 numbers? Connor? Careful. Your numbers are right. It's +5, -2, because we want to get a +3. So then we're going to write x plus 5 x minus 2. Okay, so what we're going to do is to get this big x to the third, I'm going to write it up here, x to the third minus x squared minus 22x plus 40. To factor it completely, we're going to write these two factors as well as this factor, and then it multiplies out to be that whole thing. So this is x plus 5 times x minus 2 times x minus 4. All right, so that right there is the whole thing factored completely. So really the real reason we use synthetic division is to make problems easier to factor. It can be somewhat of an extensive process. I think we did okay with it. All right, let's do another problem. Okay, so I want to factor this all completely. So let's say we're going to factor completely. Okay, so I'm going to take that x plus 3, set it equal to 0, and solve. Then I'm going to create a setup. So negative 3 goes in that box. What are the numbers across the top? What is it? You're forgetting a number, Connor. What goes in front of that x to the third? If there's no number, it's a invisible 1. Yeah, so don't forget the coefficients that aren't there. Okay, go ahead and do that synthetic division. Okay, so drop down that 1. Multiply on the diagonal by the number in the box. 1 times negative 3 is negative 3. Add going down, so we're doing 4 plus negative 3 is 1. Multiply on the diagonal. You get negative 3. Negative 3 plus 2 is negative 1. Negative 1 times negative 3 is a positive 3. add going down, and we get a remainder of 0, which is good. That means it's a factor. Okay, then I want to take each of these. What number did I start with? X to the what? What's this number right here?
Looks like 3.
It is a 3. It's not a trick question. Okay, so x to the third, that means it's going to go down to x to the 2. So x to the 2, x to the 1, x to the 0. I'm going to rewrite without those 1. So I have x squared plus x minus 1. Yes?
Why did the exponents drop down?
Because we're dividing, this is synthetic division. So what we're doing is we're taking x to the third, this whole thing, dividing by x to the first. And so what's happening is we're taking away one exponent. So if we were to do x to the third divided by x, that would be x squared, right? That's what we're doing. It's just there's a lot more to it than that. Good question. All right, so then we want to factor x squared plus x minus 1. I need two numbers that multiply to be -1, but add to be x. I don't think that works, actually. It doesn't factor. So this does not factor. Does not factor. Okay, so when we factor this whole thing completely, we'll just write it as x plus 3 from the original problem times x squared plus x minus 1. All right, and if we're finding all the zeros, we want to set equal to 0 and solve. So we'll set x plus 3 equals to 0 and x squared plus x minus 1 equals to 0. This we get x equals -3. And this one, we'll just leave it because we'd have to use oh geez, I thought we were done later than that. Sorry guys. All right, no homework tonight. Don't even worry about those other problems. We are gonna come back tomorrow and just do a worksheet, okay?
It's been a while since I've seen that. It's
I
like,
know.
had to get up and look at it a little closer. It's like, whoa, it's been a while.
I'm just so used to the hour classes. Did you do any of the homework?